Okay. The last thing that we stopped at was we talked about matter, which is anything that has mass and takes up space. We talked about pure substances, definite chemical composure, right?
I don't think chemical properties is like I've never.
So then you either need to get those from somebody or watch the YouTube video. Either one. Mixtures could be separated. Then we talked about things that are immiscible and things that are miscible. Correct? Okay, good. So today, under mixtures, we have some special types of mixtures we're going to be looking at. So I have an example of each one of these special mixtures right here. So this is a mixture. This is one of the three that we're going to talk about. It's this greenish looking thing.
What is that?
I can't tell you yet. This is another example of one of the three special mixtures we're going to be talking about.
It looks like the juice.
And this is the other example of one of the mixtures we're going to be talking about today.
It looks like it came out of egg.
So, first thing I want to show you, I'm going to be filtering these. Has anybody here ever used filter paper before? Scout has? Do you know how to fold it? No. Do you know how to fold it? Okay. So, the way you use filter paper is, because you're going to have to do this in the lab in about a week, fold it in half once, like so. Now it's a half moon. Yes. Fold it in half twice. And now it looks like, what does that look like? Slice of pizza. Doesn't look like a cone. Yeah, I'm going to do this from your view. Then you are going to pull out one tab, like so, and now I have a filter. I have a filter that can go down into the funnel. I've already done that. So while I'm talking, I'm going to start seeing if these three mixtures will filter because that's going to help us identify it. Ugh.
Does it smell bad?
I don't know, but I'm guessing that one of these does smell bad. I cannot smell anything. I told you guys that, right?
Yeah.
Oh, yeah.
Do you want to tell us that this one yellow one smells bad?
Yeah.
Ew.
I want to smell one.
Dude, I want to smell it. Let me get a sniff.
Is it that bad?
That's not how you sniff stuff in a lab. You do it like that.
Ew, that smells like. Wait, let me smell.
Anyone else want to smell it? I don't know why everybody is just wanting to smell bad stuff. It's not bad.
I mean.
Is it bad? Anyone else want to?
Put it away. It's expired something, isn't it?
Anybody else?
Rotten eggs.
No, they smell worse.
Everyone loves smelling gross stuff.
Yeah, that is bad.
Okay.
Aaron. It smells like.
Willie, what's it called?
I'm so glad that you guys could all experience that. I'm so glad. Okay. So, we have three types of special mixtures. So, we talked about mixtures. We're going to talk about, first of all, two of these are heterogeneous mixtures. So, immiscible, here we go. The first special type of mixture, this is the first thing you have to write down on your chart.
Wait,
Oh, we didn't run any of that.
Sharpeners in the back. I've got an electric one by the crayons. Is suspension. One of these three mixtures, either the green, blue, or yellow, is a suspension. So, suspension has large particles. What do I mean by large particles? Well, when you guys think of the word particles, what do you usually think of?
Air.
Air, okay? And particles in air are what? They're particles. Are they big or small? Small. All right? The particles in the suspension are so big, they're essentially the size of the tip of your pencil. Can you see the tip of your pencil? That's pretty big particle-wise. That's pretty big particle-wise. So we're talking big particles. These are so big, they can be filtered, and they settle out. So they fall out to the bottom. They fall out to the bottom. A couple examples would be bread and water or OJ with pulp. OJ with pulp. Pulp, you would agree, is a pretty big particle, yes? And you have to kind of shake it up to resuspend it. If you don't, where does the pulp go? To the bottom. The pulp goes to the bottom. So one of these three up here is a suspension. One of these three up here is a suspension. I'm not going to tell it, not yet. We have to filter them first to see if they filter out first. You guys got that? Or do you need one more second to write that down? What sports play tonight? Football? Guys, football play tonight?
Oh, no, no, sorry.
Why not?
We have enough guys.
Oh, we got soccer tonight? Against? Cleveland? Tennis is tonight? Volleyball tonight?
Yeah.
Yeah? Yeah. Anything else happening tonight? A second type. Hey, Monty, where's your paper? You should be writing this down. Okay. Is colloid. So a second type of a heterogeneous mixture is a colloid. These are your, quote, medium-sized particles. So this is a particle that you cannot see with the naked eye. All right? You cannot filter these. So they're going to look the same coming out either way. These stay mixed, and these can scatter light. What do I mean by that? Well, that means that they have the Tyndall effect, which may lead you to a question. Mr. Heller, what is the Tyndall effect? Scout, can you hit the lights?
Yeah.
So, he's going to hit the lights, and I'm going to show you what the Tyndall effect is. So, I have a laser here. All right. Can you see a little bit of the laser beam in the air? Yes. That's because it's reflecting off of dust particles. If I add more particles to the air,
Oh, yeah.
all right, now can you guys see that laser pointer in the air? That is the Tyndall effect. That's the Tyndall effect. Particles that are scattering light. That's actually kind of cool. It's actually kind of cool. Yeah. So you can see the beam. Do you guys know what 99% of dust is made of?
Skin.
Dead skin cells. So just think, every time you take a breath in, you're breathing other people's dead skin cells. What's worse, that or what you smell today? People are covering their noses now. It doesn't matter. It doesn't matter. All right, can you hit the lights again, Scout? So, Tyndall effect. Tyndall effect, that means it should scatter the light when I shine it through. So if I shine my light through here, all right, is the light getting through to the other side?
No, it's bouncing off.
But is it scattering?
Yeah.
No, it's pretty much going straight through. It's pretty much going straight through. So I know this one does not have the Tyndall effect. This one, does this one scatter it? Does it look cloudy when I shine it in? So I got some Tyndall effect there. And does this one look a little bit cloudy? Definitely have a Tyndall effect there. Okay, so 2 and 3 are the Tyndall effect. Example, egg whites, flour and water. Could be colloids, yes.
Is that what is ever in that?
I'm not telling you yet.
Yeah.
Now, colloids are disgusting. Because there's a special type of colloid we're going to talk about. And that special type of colloid is called an emulsion. Emulsions are the food that I cannot eat. An emulsion is when you take a protein molecule and you take a fat molecule and you force it together. These are not meant to go together. You take protein, you take fat, you force it together, mayonnaise. That is what mayonnaise is. Mayonnaise is an emulsion. Pretty much anything that's super creamy, sour cream, that's an emulsion. Yogurt, that's an emulsion. Are you guys getting the consistency of what an emulsion is? Yeah. All right? Your dairy creamy things are going to be your emulsions. Who here likes mayonnaise? Okay. Who does not like mayonnaise? Is anybody just mid, like it's okay? See, there's usually not a lot of people like in the middle there. It's either love or hate. Mr. Durbin, what about you?
Not a big mayo guy.
Yeah, if I have mayo, I will throw up. And I'm puke free since 2003. So I have not thrown up since the year 2003. How did I throw up in 2003?
Look, that's it, but how do you not throw up?
My body does not throw up. My wife gets sick and throws up every year, pretty much. Gets the flu. Now, 2003, how did I throw up? I was in the Pacific Ocean.
Oh, yeah.
And a huge wave hit me, and I took a huge gulp of ocean water, immediately yacked. I mean, if you get a big gulp of salt water, you're probably going to throw up. Yes?
So, that actually happened to me. we were in this thing, me and my brother were playing tackle football in the water and stuff, and there was this ginormous wave that came up, and we didn't see it because we were going in for like the catch, and because I was going in for the catch, and then I looked at the wave, and then it took me and my brother under, and I tried to take a big gulp before I went under, and then I just swallowed it, and then as soon as I got up, I just started throwing.
Yeah. Like your body is not meant to take that in. Not meant to take that in. That's the last time I've thrown up. So I don't want to know last time all of you. I don't need to hear all those stories. But when you become a parent, you learn like my daughters. If they have a fever, we know not to let them sleep in their own beds. They will throw up that night. They just do. And cleaning puke out of the top bunk, not fun.
Yeah.
I'll just leave that there. Anyways, colloids. Colloids. Now, this next picture is going to show you why I think emulsions are even grosser. This is a microscopic picture of mayonnaise. All right? So, exactly.
You ruined my mayonnaise.
That was my goal. My goal is for you to never eat mayonnaise again.
Actually, no, I'm joking.
So we have fat and protein forced together. That's what mayonnaise looks like under a microscope. So emulsions are a special type of colloids. All right. Over on the homogeneous side, we have one of these mixtures that is evenly distributed. And this is a solution. So one of these three, the blue, green, or yellow, is a solution. A solution has two parts. It has a solvent, and it has a solute. So the solvent, a lot of the times, is water. Water is called the universal solvent because water dissolves most things. Most things can be dissolved in water. These are particles so small you literally can't see them. It's going to look pretty much clear. So if I'm looking at Kool-Aid, the solvent is water. The solute is going to be my sugar. The solute is going to be my sugar. I think that this filter is so full it's not doing anything. Hi.
Hi, but what if it's salt water?
If it's salt water,
Then what's your solvent?
the solvent,
Yeah.
water.
Well, why don't they know that?
I don't know. You guys knew that, right?
No.
Oh.
Thought I tested out because I heard you say it. I was excited. Oh, you're doing the actual mixture.
I'm trying to. Yeah. One of them has already separated. So, and they all wanted to smell it. So they got to smell it if they wanted to. Yeah. So, in Kool-Aid, water's the solvent, sugar is the solute. If you want to know why things dissolve in each other, you should take chemistry and then you should take AP chemistry. I just taught my AP chemistry, we're on chapter 4, why stuff dissolves. There's actually chemical reasons. For us, it's not that important freshman year. So, solvent, solute, particles so small they can't be seen. Examples are water dissolves sugar. So, that should fill pretty much everything except for your saturated, unsaturated. Yes? On your notes. Agreed? Okay. So let's go back to our three mixtures. Let's go back to our three mixtures. Which one of these do you think is a solution? Do you think this yellow is the solution? No. Do you think the blue is the solution? Yeah. This is the solution. Can you see any particles?
No.
It looks pretty much clear. Didn't have the Tyndall effect. This is sugar, blue food coloring, and water. So this is exactly what I had on the screen. Did it filter?
Yep.
When I mean filter, I mean doesn't look any different after it goes through the filter. No. What? What? This is water, blue food coloring, and sugar. So that is the blue. All right, which one of these do you think is a suspension? It's the green.
Yeah.
Do you see how the green has literally settled out on the bottom? This one doesn't have a smell. All right? Because I know it shouldn't. In order to get the stuff off the bottom, I literally have to re-suspend it. You've got to shake it up. This is a suspension. This is water, green food coloring, and flour. And flour. This should have filtered, but you can actually see a little bit came through. Do you see how it looks clear, the stuff that came through? How it did filter it out. My filter is clogged. So that's why nothing is coming out. Willie.
What's the yellow one made out of?
So the yellow one is a what? If it's not a suspension or a solution, that must be my colloid. This is a colloid. This is water, expired milk, and yellow food coloring.
Why?
Because the milk hasn't been refrigerated and it's been sitting here a couple days. So congratulations on. It was not one of the examples that I put up. So I don't know, 2 days worth.
Oh, that's it.
Yeah. Luckily, we're not the last ones to use this. Mr. Knight's going to use this like tomorrow. So, so those are your special types of solutions. Questions on those? Put your notes away. Put your notes away. Get out your yellow sheet. Your yellow sheet. Get out your yellow equation sheet. On your equation sheet, you guys are going to see an equation that says density equals mass over volume. Do you guys see this on your yellow equation sheet? Do you guys see that? Somewhere. I should probably get one to toss this under my... Well, you guys, it's fine. I don't need one. Do you guys see density?
Yeah.
It's on the front lower right. Yes? Have you guys ever seen an equation triangle? So I would have density here, mass here, volume here. Who's ever seen an equation triangle? Only 2 people? Your math teachers aren't showing you this stuff? Okay. So mass is usually measured in grams. Volume is going to be centimeters cubed or milliliters. Is this what your equation triangle says? Yes? Might say milliliters, might say liters. Sometimes it's centimeters cubed. And density is grams per milliliter. How do you use an equation triangle? Anyone still have that milk smell up their nose? Ariana, you still got it? No? Okay, good. You just trying to block dead skin cells from going up there? Okay. So, if I cover up one of these variables, it is going to show me how to solve for the other ones. So if I cover up density, what does that leave me? Mass is on top of what? Volume. So D equals M over V. If I wanted to solve for mass, I would cover up M. If I cover up M, M equals what? They're beside each other. So the mass is density times volume. So M equals D times V. This is on your equation sheet. And if I wanted to solve for volume, I would cover up volume. Cover up volume. So volume is going to equal mass divided by density. Why have your math teachers not shown you this?
I think last year Mrs. Hispanic showed that.
Okay. Your science teacher might have, but like this is a really super easy way to rearrange algebraic equations. So if you have any algebraic equation, you can probably put it like this. So V equals M over D. Do you have those 3 equations on your equation sheet?
Yeah.
Okay, great. So we are going to be doing some density math practice. Scout, can you grab me one of the papers back there quick? So we're going to do a little bit of actual math practice with this. I don't need a ruler. I don't need a ruler. Thank you, though. Okay, thank you. So let's take a look at a couple density problems. Let's look at number 1 on this sheet. Can somebody read number 1 out loud for us? Volunteer. Lyra's got it.
What is the density of a block of wood with a mass of 350 grams and a volume of 185 centimeters? Is that cubed?
Cubed, yes. So number 1, they're asking me to solve what? Density. What am I given? 350 grams is the what? Mass. And 185 centimeters cubed is the what? The volume. It's the volume. So I'm trying to solve for density. Do you see how I circled or squared what I got? It's a good way to mark your problem to say what you got. So I'm trying to solve for density. We're going to be using what to solve math? What do we always use? Yes? Three-line method. We're going to be using three-line method. So step one in the three-line method is what? Write the equation. Equation for density is D equals what? M over V. D equals M over V. Step two is sub in numbers and units. Let's do it. So D equals 350 grams divided by 185 centimeters cubed. Do you have a calculator? You're definitely going to need one. Definitely going to need one. You guys know your Chromebook has a calculator on it too, if you ever need that. Just Google a calculator or use Desmos.
We're doing
Divided. Divided. Hold on. Give everybody else a chance.
Should we put the line
What line?
to show that meeting?
No, because we know how to round. What is our fancy way to round? Sig digs. So, before I write my answer, I have to think to myself, how many sig digs are in this number? 2. Would you agree that this is greater than 1?
No.
Does it have a decimal? So does the 0 at the end count? No. 2 sig digs here. How many sig digs here? 3. What's less? 2 or 3? 2. So what did your calculator spit out? Caden.
My calculator spit it out 1.89 repeated.
1.89 repeated. So that's going to round to
1.9.
1.9. What are my units?
Grams.
Grams
Centimeters.
per
Oh.
centimeters cubed. Grams per centimeters cubed. You guys want to try 2 on your own or do one more together?
One more together.
One more together. 2. A tennis ball has a volume of 75 centimeters cubed and a density of 1.05 grams per centimeters cubed. What is the mass of the ball? So in this one, they gave us V. They gave us D. Agreed? What am I going to be solving for on this one? Mass. Do you see how just circling or squaring what you are given will kind of help you solve problems like this? Make it more visual for yourself. Do we have an equation for mass on our yellow sheet?
Yeah.
Aiden, what is it?
Oh,
What's the equation for mass on your yellow sheet? M equals what? Lower. Keep going, keep going, keep going, keep going, keep going. Lower, 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 lower. Right there.
oh, right here.
Yes. What? Mass equals. Wait, what does this say? Okay, there's a mistake on your sheet.
Yeah.
It should not say P times V. That should say D times V. Should say, so fix that. On your yellow sheet, that should say D times V, not P times V. This equation editor put it in P. P's momentum. That's why I put in P instead of D. They've already fixed that. M equals D times V. And then did you fix your volume? That's M over D and not M over P. Fix both of those.
Oh, so where's that?
So volume below that should not be M over P. That should be M over D. M over D.
So P is D.
So P's should be D's. P's should be D's. Did you guys fix both of those on your yellow sheet? Yeah. Okay. So here we go. Step 1. M equals, what's the equation?
M equals D times.
D times V. Step 2. Sub in numbers and units. So M equals 1.05 grams per centimeters cubed times 75 centimeters cubed. So M equals, do you see, think about units here. I have centimeters cubed on the top and I have centimeters cubed on the bottom. When I multiply those together, what's going to happen to centimeters cubed? They're going to cancel out, right? So put it in your calculator. It's just going to be G. It's going to be G. Lyra, what'd you get? What'd your calculator spit out? $78.75. Did anyone's calculator else spit that out? Yes? Lyra, how many sig digs do I need though? 2. So 78.75 is going to round to? 70 what? 78.7 should round to 78 point. Wait, what was it? 78.75? So 78.8. Yes?
Aren't we only supposed to have
All right, hold on.
one equals
That'd be
up to
79.
Oh yeah, so 79. So it'd be 79 grams. Sorry. I was trying to do that in my head. I should have done it on mine. 79 grams. Does it make sense why I only have 2 sig digs?
Yeah.
Try number 3 on your own. Yes. Yes.
Wait, I gotta put it in here. Because when I see it only, the minimum is 1 sig dig.
So we have to round that.
So,
You're right. Your
100.
answer is correct.
oh, okay. Just like check.
Don't let sig digs confuse you on number 3. Just do it to sig dig rules.
Mr. Allen.
Yes.
So for the number 100, these zeros won't count, so it'll just be 1 sig dig.
Correct. Yes. Yes. Yes.
Were we supposed to have 2 sig digs for this one?
You tell me.
Because it's, but the number is 133.
How many sig digs are in your numbers you start with?
2.
How many sig digs?
100 and then.
How many sig digs though?
Wait, 1.
1.
So I'm
So your answer
thinking-
can only have 1.
But the answer's 133.
I know. So you got to round. So you got to round.
Oh, okay. You have to do the ones in the back too.
Hold on. Eventually. Yes. On this one, what am I solving for? Volume. What is the equation for volume? V equals M over D. Good. So we know how to use the equation sheet. Head nod if you feel good about using the equation sheet. Okay. 7 are numbers. V equals 100 grams divided by 0.75 grams per centimeters cubed. I subbed in my numbers. What did your calculator spit out?
133.3.
Your calculator spit out 133 something, right? But how many sig digs can I have? 1. Because how many sig digs are in 100? So this shows you why it's so important to have precise instruments. This instrument was not very precise. So what does it do to our final answer? We have to round it a ton. Yes? So 133 is going to have to round to just what? 100. You got it. So this is just going to be 100 centimeters cubed. 100 centimeters cubed. So that's what sig digs are for. They show me this was not a very good instrument that we used to measure with, so therefore my answer is not very precise either. On this paper, there are a total of 10 problems. So, how about you guys do odds? The odds remaining for tonight. So you guys do 5, 7, 9. You can work with the partner the rest of the period. I'm cool with that. 5, 7, 9. 5, 7, 9. You could probably finish this in class.
Have you ever heard smelling salts?
Yeah.
Smelling salts? No. Also, can I close this book?
It's like, do you think if Lorraine just shoves up your nose?
That would probably, it would still wake me up.
Yeah. It kind of stinks.